Okay, the last idea that we haven't looked at from this section in 2.8 is doing second derivatives with implicit differentiation. So let me work through this one with you. Well, how many of you have found the first derivative of this already? Not many. So let me have you do that. You do want to isolate the dy dx before we take the second derivative. So start by finding the first derivative, and then you can just stop, and then I'll work on it with you. There's my first derivative. Suggestions? What should I do next? Ryan? I could cancel these out. I'm not going to, but it's not wrong to cancel it out because I have this denominator as part of my numerator. So I'm going to end up multiplying everything on top by nx plus 2y anyhow. And so that's the one I'll cancel out, or not. Could cancel these out and then just introduce that one to the first term later. If I do that on top, I have to do it on the bottom as well. So then my first set of terms, I'll have that negative plus 2y that I just multiplied in, and the 2 minus y left over. And then I'll keep that 2 minus y, and inside my square bracket is where I'm going to distribute this x plus 2y in. So that'll give me an x plus 2y times the 1 plus 2 times the numerator, 2 minus y, and the denominator canceled out. That'll all be over top of the x plus 2y, now cubed. questions up to there. So now I could expand out the numerator, or I could factor out a 2 minus y. I don't know what's going to be best. So just out of habit, let me factor out the 2 minus y. I may end up multiplying it in later, but I'll start by factoring that out. So now I'll simplify inside that square bracket. Actually, I'm going to get rid of that negative right away. Just distribute it in. So I'll have a y minus 2 in front. I have 2x's, 2y plus 2y minus 2y gives me a plus 2y plus 4 all over x plus 2y all cubed. Up to there, how are we doing? I'll show you.
So back when you had a 1 in the equation, I would have 1 plus 2 divided by right?
So way back here, where I have this one. Yep.
What I did was I turned it into x plus 2y over x plus 2y.
Okay.
So everything would be under, the same.
Over the common denominator. Yep.
Then I got x plus 2y in my thing instead of 2 minus y. You got 2 minus y there. So I couldn't factor out with 2 minus y.
But this 2 minus y was still there.
Yeah, but why do I have that? When you do that one, I was thinking I would just put everything.
Okay, at this point, I'm going to look at this last line, and I'm going to look back at my original function, xy plus y squared equals 2x. I don't see anything like that. So I want to find it. I think it's probably hidden there somewhere. So I'm going to multiply this out in the numerator to see if I can find those terms. So what do we have? First term is 4x plus 4y minus 8. We're not there yet. It will be more simple. So this is where, after doing the previous question, I said, in this question, by pulling out this common factor, I was able to find my original function. And I said, sometimes that's helpful, but other times we actually have to expand. So that's what we're finding in this question. We need to expand this out in order to find our original function hidden in there somewhere. So let's collect some like terms here. 2xy. This 4y and minus 4y cancel out, which is kind of nice. Plus 2y squared minus 4x minus 8 all over x plus 2y all cubed. Now again, I'm going to go back and look at my original function, or equation xy plus y squared. Let's look at that piece. Yeah, we'll factor the 2 out from there, and then we'll have an xy plus y squared. So this piece is my original function, and I know that that is equal to 2x. So I'm going to have 2 times 2x minus 4x minus 8 all over x plus 2y cubed. What do we get? Negative 8. Or x plus 2y all cubed. And some of you are saying, how is this simpler? That's pretty simple. It just took a lot of work to get there. Do you have to do this on the test? If you want full marks. But likely what I will do is up to what point? Well, let's say up to this point or this point, somewhere there, you get all but 1 or 2 marks. And then you just get that extra mark. Maybe 2 marks, do a little more than that. Question?
Is there any possible way to double check your answer? Like just believe it?
If you're finding the original function, like we did here, that's a really good clue that you've done everything right. Is there a way to double check? If you had access to Desmos, you could do some graphing to double check, but well, what you could do is you could pick an XY ordered pair that works for this original function and then plug it in at this point and see if it's the same thing as you get at this point. But there's always the question, how do you know you're right up to this point? Yeah. Okay, Mohamed? This one up here? Yep. I have not found a situation where it's not in there somewhere. Yeah, either it's there or you expanded out to find it, or you made a mistake somewhere. But at some point, you just say, I've done all I can do. I'm going to leave this question and get the part marks I can get. But don't erase everything. Leave me some work so I can find part marks. Aska? I could have factored the 2 out from the whole numerator, but I'm really focused on finding this here. Yep. Where we had the 2x? Where did I have a 2x? At this point? I could have, but then I'm going to get an xy and an x squared, which isn't going to simplify that second bracket. I'm still going to have to expand. So I could have done that earlier. Yep. So there's more than one way you may choose to substitute from that original function. Yep. Rayan. That notation? Yep. So I'll pause. Okay, your attention, please. First derivative. Everybody good with my first derivative? Yep, that's going good. You need what? Oh, okay. So then we'll do the derivative of this. That'll give me the second derivative. Low d high minus high d low. Square the bottom, there you go. And at this point, we can plug in numbers. Who wants me to plug in numbers? Who wants me not to plug in numbers, just see how we can simplify? Okay, I think I probably have it both ways here. Let's see. So here I plugged in the numbers. What did I do with that? Oh, there we go. So first I found my first derivative at the point 2, 1 is 3/4. It's a little faint, but where you can see a bracket and hardly see a number, that's a 2 in there. That's the x coordinate. And we get -13/16. Dun, dun, dun. What's the what if? Yep.
You explained the last bracket on the top.
The last bracket on the top. Okay, so where I do yep, so here I did low d high minus high the d low, because I have my first function 2x. It's first, there's my second function, so times the derivative of the second, plus my second function, which is y. Derivative of 2x is just 2. So that was the product rule. Okay, we have 2 and a bit minutes left. So let me see what this what if is. I imagine this what if is if we didn't have numbers to plug in. There we go. So for those of you who wanted to see what happens if we just went all the way with variables, didn't plug in any number, there's my second derivative with the substitution. Okay, so there I replaced the dy dx with my first derivative, which was 2x minus y squared all over 2xy. Then we need to do some simplifying. So I'm going to multiply everything by xy, 2xy. Everything on top and bottom. Oh, wait. No, I just simplified. Oh, there we go. So what I did at this point is this 2y and that 2 and y canceled out. Oh, actually, don't even do that. When I distribute this in, the 2xy cancels out with this denominator. So I don't have a 2xy. Over here is where the 2x is canceled out, so I have just the y in the denominator. Then I'm going to get rid of those denominators. multiply by y over y. There's that.
Can you scroll up so I can take a picture?
I'm finishing this off for the video. There we go. Final answer. Simplified form. Notice here. Way back at the start. Oh, not way back. Oh, yeah. Simplified down. Final answer. Stop there. Ta-da!